Hello everyone, so I want to record hopefully a quick video about, well, this thing. So guess what is the most used component in the manufacturing industry? Exactly, it's pneumatic cylinders, but linear guides and rails are up there too, and I wanted to do this for a long time, and actually I did print these rails, just naively downloaded the model of the linear guides, or, well, yeah, guides, I guess, the carriage thing, and printed it with few offsets and tried to put it on the rail. Of course it didn't work, but anyway. So then the question is, why would you even want to do this? Because obviously the price or the cost is the objective here. I printed these. These are individual carriages. I don't want to cut myself because there is sharp corner on this rail. So I've printed these in 20 minutes. So that's nice, really. And these rails aren't even that cheap, because if you want to reduce cost on your machine, you would use a supported round bars. Well, I have worked in a factory where they used rods basically for linear guidance, and the thing is that with these rails you never have to replace them. They never get damaged pretty much. But with the linear rods, like the balls get imprinted into them, because you have basically point contact. This is line contact, so it transfers the forces much better. I mean, you could argue that with supported rod you could print even simpler geometry, and I guess that's a valid point. Well, anyway, but what you can't do is have well, this is cutting edge, but anyway, you cannot have one thing that is supported in pretty much all directions, but just 1 degree of freedom. And so I guess this is what is it for. Now, even if this would work, I don't think this is a good idea, because with steel balls, again, you have line contact point, and so what is the integral of that? I guess few millimeters of contact basically. And so yeah, this is plastic and it's obviously much weaker in bending radius, but as far as linear guidance for not heavy duty stuff, this would be more than enough. I could probably go with even thinner profile, but you need some holes there obviously. So I've quickly realized that this arrangement would be probably more than enough for whatever you need, I guess. But also, if you have a very light duty part, you can pretty much do this long fucking thing and mount it on just these 2 points or these 2 elements, and have the whole thing basically move like you want it to. So then the next step would be to create profile like this. This is pretty much the whole side of the thing. I guess I can put it on. But then I was thinking, well, sure, these are some nice big surfaces that are providing, well, something, but actually, are they providing anything really? Because the only thing on the real carriage, the only thing that is transferring the loads basically is this and this circular arc profile, and obviously mirrored here. So this is doing nothing. And even on the plastic part, you would think that, yeah, sure, some more surface contact would be better, but actually you can bend this, and if you bend this thing outwards, would it do any work? I don't think so. So I've simplified the profile to basically only include these 2 arc profiles, and made it a little bit wider, and also, yeah, that's it, just a little bit wider. And so because I was able to bend this with my fingers, you can obviously probably see what the limitations are. And right now I'm unprepared, but okay, let's print this a little bit taller maybe, obviously, that will help definitely. But what you can do, imagine that this is not aluminum foil, but like, I don't know, 2 millimeters of stainless steel. You can get this laser cut for pennies basically, and you can pin it with this whole thing. And idea is that you would basically have a thing that is stiff as the stainless steel, apart from the what is it called? Well, apart from the material strength itself, because you can squish this like this, even if you really press on it, obviously. But that's not the point. So basically, you can put metal on this side, and if you want like I don't know, like really heavy duty, you put this here, another piece of metal, this here, and this will be strong as fuck. Now obviously with that comes more problems, because if I put this here, I can basically do this, but if I put free, there is some... Oh geez, this is quite hard already. There is some friction, obviously, because there is no rolling elements, so this will be much harder to move than steel carriages. And finally there is question of accuracy. I have printed these parts in this orientation, so what that means is obviously they are a little bit more away from first layer, so that tends to be very inaccurate. First, I don't know, 10 layers. This is 30 layers basically. I print with 0.1 millimeter step. Then this is obviously a reject, so never mind that. But the edges tend to be uncured, so you need to clean this with ethanol, but that removes some material, so this cannot be super precise. I guess fortunately or unfortunately, the accuracy on here basically is abysmal. And so what I have done is I have marked this with Sharpie, the arc segments, I guess you could call them, and I have cut this rail like this with just a Dremel, nothing special. And so this creates a sharp edge basically. What you do is basically you do this. And this will remove some material. You can probably see it, just barely, but there is not much material to remove because I already did this. Originally I have sharpened this face, and I was thinking about using this as a brooch, but like I don't have any stable enough guides that would allow me to do that. Anyway, so this would be good enough. However, where the accuracy gets you is right here, and I'm not able to show this, of course. Wait a second. Let me shed some light on the matter. Yeah, so you can see that these are not very great. I mean, they are not terrible. The difference would be like 0.1 millimeters, but it is not great. Now, a few more notes, I guess, before I destroy a few of these. This was printed with this gray plastic because it is or gray resin, because it is the most accurate resin I was able to find. So this is great. However, it is not greatest resin. This blue one has quite some very nice properties, I guess. I'm not sure if it is sold as engineering resin, but I don't even have my knife with me, but you can basically make a thin slices with this material, so it is like, I guess, waxy, you could say. Normally these resins break off, they produce, what is it called? They break like glass basically. This one is much tougher, and so that is very nice. However, it is not that accurate when you print it, because it is transparent-ish and the light leaks. So you can tweak the fucking printing parameters, but I'm pretty sure that this would be like 10 times better than this. However, what would be 100 times better than this would be to not print this, but mill this from polyoxymethylene plastic, because that plastic is absolutely amazing. It is like, however, I do not have mill, otherwise I would do this. Well, I think it would be much more work to mill these, but and also there are some yeah, there are some sharp corners, I guess. In any case, if you want to mill this, there are sharp-ish corners here. I think I put radius there, like 0.3mm radius, so you know, you can mill the whole thing from this side, but yeah, good luck. These radiuses are 3mm, so you can probably come in with 3mm and mill, well, ideally 2mm or something like that. Mill this from one side and flip it and come in with like, what is this, 15mm, so with 12mm and mill and be done with it. However, the thing with polyoxymethylene is also that they do not have flat sides, so if you mill this, you would probably want to mill this from the face, then do the contour, then do this thing, then flip it around and do this face, if you want to stack this like this. Otherwise, and even if you want to stack this, when you remove this support, so even if you print this, you will see that there are some nasty things, and yeah, it's not great, really. And so question is, can I break this? I think that the glue here, this is CA glue, will be stronger than the plastic piece, so I think I will be able to break this. However, I'm not sure if I have a heavy enough base, because I will try to use this table. It is 15 kilograms of force. I don't think I will be able to break it with that force, but let's try. Yeah, one clamp should be enough, I would say. Now let's put this here, and this is some random piece of string that my cats are not playing with right now, so I will use that. And alright, so glue failed, so I guess that's a data point. Let's try maybe this. And this is where normally the force would go, I guess. So let's try this. Yeah, 15 kilos, and it is holding there quite strong. So, well, I want to see, and I can measure this. How much force does it need to bend this way, basically? I cannot measure deflection. Well, I could if I subtract the deflection of the rigidly mounted U-profile, aluminium U-profile, but it is fairly thin, so there is good chance I will destroy the aluminium profile now when I'm looking at this. Anyway, we can try. So let's do this quickly. I have 5,008 grams of water here, and so this is fairly long arm. I will need to mark where I will be measuring at, I guess. Well, here obviously it works, so let's measure here, 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 here. And one of these will fail. I guess I can help it a little bit too. Oh boy, this is not very great. Yeah. This is drooping like crazy. Yep, this failed. This failed unexpectedly. Well, okay, so it was not that unexpected. It probably failed here, and then due to shock, it failed here. But you can see that this wee tiny bit got yeeted away. So, well, that was interesting actually. So I had to look at the video where exactly it failed here, because, well, the moment you don't look at the screen on the camera, the moment the autofocus go, whee! Anyway, let's calculate how much this is from the center of the rail. That way you can calculate the moment. Well, let's calculate from here, I guess. And that is barely 16 centimeters. Yeah, more like 15.5. Okay, let's calculate the moment, I guess. So that's 50 newtons times what is it? 0.15. That is 7.5 newton meters, which is not great. According to specs from manufacturer, the carriages, like the whole thing like this, could support 120 newton meters, so this is roughly 17 times less than the normal thing. However, that makes me even more curious about the limits of this in like this axis, because like if this carriage is like this wide and it is not this wide, it is only this wide, there is just some rubber things, and this is able to support 140 newton meters in this bending moment, then if this is 17 times less, that should be about 8 kilograms on a point-like load, which I would argue is kinda sorta is, but this did absolutely nothing like lifting 15 kilograms up, so... Well, 50. I measured it by hand, like lifting it. Ah, yeah, that's like 15 kilograms. Well... Yeah, 9 kilograms. Okay. Well, that's interesting. Okay, so if I have 9, then times 2, this... So this should be able to support 18 kilograms in this direction, also perpendicular to the rail, like, surface, I guess. Front surface, top surface. Yeah. Okay, so that would be reasonable. Okay, wait a second. So this means that if I put another 5 kilograms on this table, I should be able to break this. So let's just test it. So I will add a little weight on top of the table, and let me do this. Okay, did not break yet. Let's add more weight. Holy shit, if this goes, I will have even less teeth than I have right now, so that's not good. Yep. I think then that my calculation was about correct. So about 15 kilograms of pulling force on this is like breaking point, and again, this is a very fragile resin. This would be much better material. If you would use polyoxymethylene plastic, it would be probably like 10 times as good as this is, even though it would probably just bend and open up and go away from the rail, but still. But then again, if you imagine you have like two rails 100 millimeters from each other, then a plate mounted on these elements, you would have basically capability of 30 newton meters of torque applied here, which is already not small number, plus this will capture some force. So, but then if you know that you will have torque, then just do this. If this will be one-sided torque, and voila, you have already some 60 newton meters at least capable thing, which is a lot of newton meters. But again, you should not do that, because this is for light-duty machines. So anyway, then again, there is question of durability and precision of these blocks, and I have experience of running epoxy resin blocks around hexagonal rods, which one was cold rolled, one was hot rolled, and it is not great, but not terrible. If it wasn't cold outside and my storage was a bit better than it is, I would show you about what the play is, but I cannot show you what the play was. And there was some play, there is a little bit more play, but again, this was on a steel profile, basically bought from the steel mill without any nice treatment to it. Yeah, I washed it with acetone and stuff like that, but these surfaces are ground, so they are very smooth, and I would imagine that this could develop some, I don't know, few microns after a few years of usage, but and also it is plastic, this is steel, so you are dependent on temperature, so you better print this at 20 degrees, I guess. No, but yeah, really, I guess, yeah. So if these are considerably hot, then you will have play. So the question is, should you build CNC out of this? Well, depends. If you want to mill aluminium or steel, probably not. If you want to mill plastic, well, maybe. So I can order a few of these rails and I can try CNC and we'll see how capable this is, but I don't have enough motors right now and enough belts and stuff like that, so I will have to buy more stuff, and I don't really want to spend money too much right now, so we'll see. But I will need to order these anyway, so what I want to do and what I need to spend money on is this thing. And it is good question, what the fuck is this? So there is this wiper motor and there is a blade that cuts the pasta, because I had pasta maker that was like rollers that cut the pasta, but I was not happy with geometry of the pasta, I guess I could say. How this worked was quite complicated. You see, there is this thing with two rubber belts, and there is also some pasta still in there. And this basically, this fed pasta here and this cut it. So it was like, I don't know, 1 millimeter in, cut it, or maybe 1.5 millimeters probably. And so this generated fairly consistent pasta, but this feeding mechanism did not work too well. So my idea is basically to put rails on here and put this whole thing, make it a portal, and move that across the static pieces of dough. And so I kinda hope that this will work much better, because I have too many eggs and I need to use them. I thought that the chicken would stop laying eggs during winter, but apparently they just slow down a little tiny bit. And because I thought that they will stop, I have made this much of pasta, but this is different process. This is like it is basically granulated pasta like this, and I can make this very efficiently, time-wise, because I'm still doing a lot of stuff around the house, and so I was like, okay, I need to streamline this process, so I think I make like 2 kilograms in 30 minutes, but the point is that I wanted to taste something different, well taste. It has different texture than if these are cut in a straight line, I guess. But this process is actually very interesting. You need only a mixer. Well, not any mixer. It needs to have a metal thing that goes through the glass, otherwise you will break it, and also it needs to have metal, this thing, and the mating surface is also metal, so it needs to be fairly heavy duty, but I can make video about that, why not, I guess. Anyway, so yeah, that's probably all about the thing I wanted to show you. So see you next time.